Imagine your most important engineer disappearing during the most critical phase of your deployment. It's pretty terrifying, right? Well, FlowFuse experienced this in real life just a few weeks ago. In the lead up to Handover Messe 2026, I found myself stranded. I was stuck in Japan, several continents and time zones away from where the deployment was going to happen in Hanover, Germany. It was a perfect example of the bus factor in real life. Not only was I stranded, the entire server stack that our demo depended on was stranded with me. 24 hours later, our full stack was up and running. Hey there, my name is Christopher Sandoval. I'm a developer relations advocate here at FlowFuse. Now this Thursday, we have a webinar getting into the technical details of how we did it. But today I want to show you how we use FlowFuse to deploy in an undeployable circumstance. So with that said, let's dive right in. So this circumstance was entirely unforeseeable. This wasn't something that you could have architected away. This was a nationwide strike that meant that there was no transit to Germany. And that's the kind of problem that the bus factor is meant to represent. The idea behind the bus factor is pretty simple. How many people could you remove from your stack and still have the stack survive? It comes from a pithy joke. What happens if your lead architect gets hit by a bus? If you have one person who's critical to the process and they're removed, you have a bus factor of 1. If you have 4 people in quick succession that would have to be removed before it collapses, you have a bus factor of 4. But while you can't plan for every externality, you can build your system to be resilient even if those issues come up out of the blue. So today I'm going to give you 4 architectural solutions that you can apply to make your systems more resilient and make sure that you can recover from a problem just like this one. Fleet level deployment and orchestration. When you run into a circumstance like this, it's not really reasonable to just fly someone out. In many cases, that's going to be prohibitively expensive. In my case, it was just simply impossible. And so needing someone on site to deploy something, that doesn't make much sense. What you instead need to do is build in fleet level orchestration. Now what fleet level orchestration actually means is giving your engineers the ability to deploy remotely and centralize the entire process. FlowFuse has centralized CI/CD pipelines built directly into the product. So if you're in a circumstance where you have to build out a server from nothing, you can take all of the flows that you have previously and all of the documented systems that your stack depends on, and then you can roll out that deployment en masse. This allows you to rapidly iterate and self-heal. If the process of healing a critical failure takes hours and hours and hours, well, that issue isn't just isolated to the single issue. It compounds. If one device takes 10 hours to repair, but you have 100 devices, well, then you're not coming back anytime soon. Centralizing your orchestration and deployment means that you can take the fixes that you have locally and then send them wherever they need to be. Safer delegation with granular role-based access control. Now, because I was so removed from the build process itself, I needed people on site to be able to basically act as me. But the problem is that there were a lot of systems that I needed them not to be able to touch. And even if I had documented everything, these systems were safer to run locally with me than it was to actually send over to the build crew. And so suddenly I was in the situation where the initial devices that I had set up, which had pretty open permissions, needed to be controlled in a much more granular way. Essentially, I needed to delegate the ability to build without delegating any of the generation of risk. FlowFuse provides granular role-based access control for exactly this sort of situation. By using granular role-based access control, I was able to make sure that the team had the permissions they needed to roll out locally on site, while still controlling all the things that I could control locally or things that needed to be handled with a higher level of privacy or security. This meant that the team could move quickly. They didn't have to wait for approvals from me for every single piece. They could roll out production devices tied to existing data, and as long as they didn't cross a line which was very clearly documented, they were able to do basically anything that they needed to do. This meant that I was able to centralize all the things that had to be centralized to the servers that I had in Japan, while delegating the build process for the local demo to the people that were in Germany. And the best part of it is that all of this was built into the FlowFuse platform. Unlike other solutions that would need role mapping or alignment to port forwarding, I didn't have to do any of that. I basically just invited people to the team, assigned their permissions, and then started my work. It was quicker, easier, and more secure. Observability instrumented during development. Adding metrics while you're under pressure gives you the wrong metrics. But I still needed to know exactly what we were working with. I needed to know whether there was any dropout of the internet connectivity. I needed to know how fast the devices were processing. I needed to make sure that all the devices were working together and that the data was flowing in a way that I expected it to. This was especially important with the local LLMs. Being able to see exactly how many tokens we were using, whether we were saturating the local network on the Hanover side, and whether we were getting low enough latency between my servers and the remote devices was critical to making sure that the demo actually worked. And this is an important factor for the modern factory. Connecting all of your devices is one thing, But making sure that those devices are doing what you think they're doing, and making sure that you're meeting the expectations and the SLAs of your entire stack, well, that's an entirely different beast. So during our initial build process, we made sure to actually build in that observability as part of the code itself. Everything had a metric, everything was tracked, and everything was tagged. LLM requests were given IDs. When we went from instance to instance, we sent device IDs with every request, and we basically made sure that the entire system was communicating its status all the time. By communicating the status and understanding what each node was doing, we were able to troubleshoot really specific problems that arise only because we had the server with me in Japan and the demo in Hanover. And the good news is that this data is built into FlowFuse. You can get all sorts of data from the devices themselves, but you can also generate your own data every single time you say call an API. In this sort of circumstance, context is king, so give yourself as much context as you possibly can. Snapshot and rollback as a discipline. Now here's the thing that really saved us. Because FlowFuse has such powerful snapshotting capabilities, I was able to take all of the data that I had on the devices with me that needed to be rolled out in Hanover, and basically just copy that entire instance and export it to a device. The ability to automate and control your CI/CD from a central plane means that when you run into a circumstance where you need to, say, clone an entire section of your server stack, you can actually do that in a couple seconds. You don't have to go in and manually copy and paste. Now the rollback part of this was equally important. It's not good enough to just be able to send out your snapshot. To be able to send out your snapshot, test it, iterate on it, and then roll back when something fails, well, that gives you the ability to quickly respond as you're trying to build out this new stack. And when you're moving things from one device that you're holding locally to a remote device that you don't actually have direct connection to, well, that's super important. This meant that our teams could work in shifts. I could be working remotely while they were sleeping, and then when they woke up, we could go through all the stages of iteration and development. If anything needed to be fixed, we could roll back, and then I could hand off the project to them and go to bed myself. And then when I woke up, we could do another review, and so on and so on. The ability to rapidly develop to generate snapshots and roll back gives you a crazy amount of flexibility and gives you a ton of malleability as to what you actually develop. Check out more this Thursday. Now this Thursday, I'm getting into all of these topics and more in a much more technical sense. These are pillars of this strategy, but in order to actually make them work, you need to leverage something like FlowFuse to build them out at scale. If you check the link in the description below, you'll find the webinar about this exact topic. I'm going to be diving into this topic in depth to show you exactly how the problem happened, how we responded, and what practical lessons you can learn for your factory. We're going to get very highly technical, so if any of this piques your interest, I would definitely check out that link. We hope you liked this video. If you did, please give us a like, comment, or subscribe. If you want to get started with FlowFuse, then head on over to flowfuse.com to start your free 14-day trial. This has been Christopher Sandoval. Thanks for watching, and I'll see you next time.